just one less than, one greater than. When two simple inequalities are combined into one statement by the words and or, the result is a compound inequality. Okay, so you're going to have two of them, either with the word and or. So take a look at that chart you got on your paper. This is just what we went over. We said all the numbers greater than 2 and less than 6. Okay, you can write it two ways. I can say x is greater than 2 and x is less than 6, or I can do this little statement that we had earlier. This is the graph. The only difference between the first and the second one is you can throw in the word equal to. Okay, greater than or equal to or less than or equal to. So then you have solid dots. The word or, however, is a little bit different. Okay, because it includes both answers. And it has to be true for both cases, or it can be true for one case. So the number is less than 2 or bigger than 6. Less than or equal to or bigger than or equal to 6. Okay, as well. Now, these are the type of problems that we need to be able to come up with a final graph. Just look at that. That's one's on your notes, isn't it? That little. Okay. If it has the word and. So think about this. I want all the numbers that are less than 10 and greater than 0. You look for where they overlap. Okay. So less than 10 will go from here, greater than 0. Overlap will be in between 0 and 10. That's essentially what we're going to look for. All right, I just want you to look at this one here. That's not on your notes. This is the type of problem we're going to solve. It looks totally different. What we want to do is we want to get x by itself in the middle. What's in the way? Plus 1, right? Well, if there's a plus 1, how would we always get rid of a plus 1 in the past? Subtract it. But now I kind of got two cases. I got a left and a right. So you're going to have to subtract 1 over here on the left, in the middle, and over on the right. And so that's going to give me negative 6 is less than x is less than 1. Once I have it in that case, it's trapped in between negative 6 and negative 1. Or 1, positive 1. So that's what we're going to have to do. So if you take a look at that first one here. All right. So this one's on your guided notes there on the bottom. Negative 7 is less than 3x minus 1. We want to get x by itself. Just like an equation, first thing you want to do is add. So you're going to add 1 to the right-hand side, to the middle, to the left. That gives me negative 6 is less than 3x less than or equal to 12. Okay. I still need the x by itself, just like an equation. What do you think we should do, Ellie?
You would divide the negative 6 and the negative 12 by 3.
Yep, you divide by 3. We're going to divide all sides by 3, including the middle, just like she said.
Yeah.
The negative 6 by 3 and the 12 by 3. I get negative 2 is less than x is less than or equal to 4. I like to write it like this. I like to keep it like this. Now, this is also the same as saying, I want you to think about this. You can also rewrite that with the x first, and you can say x is greater than negative 2 and x is less than or equal to 4. It's saying the same thing. Now, you don't have to write it like that. You can leave it just like this. Now, what's its graph going to look like? So I want all the numbers that are bigger than negative 2 but less than 4. Since it's just less than or greater than x, you have an open dot at negative 2. Since I have a less than or equal to, I have a solid dot at 4. And we need to connect between. So that's what it's going to look like. All those answers are going to be true. All right, let's test one of them. Give me one number in that interval. Yeah, make it a nice number.
2.
2. So we're going to check x equals 2. So now let's test it. And you just pay attention here. Plug in 2 for x. What's 3 times 2 minus 1? 3 times 2 is 6. 6 minus 1 is 5. Is that number bigger than -7? Is that number smaller than 11? So this is one of our answers. Okay. So any number in here will work. Any number outside of here won't work. So 5. 3 times 5 is 15. 15 minus 1 is 14. 14 is not less than 11. So it's got to be in both cases. All right, so take a look at this second one here. Let's solve that one. -4 is less than or equal to 3n plus 5, which is less than 11. Get the n by itself. So I'm going to subtract 5. Okay. All right, when I do that, okay, Mason, what's it give me?
Oh, 1 is.
Ooh, not 1, not 1. Be careful.
-9.
-9.
Is greater than or equal to.
How do you read that one?
Less than or equal to.
Less than or equal to?
3n.
3n.
Less than 11.
Less than what?
11.
What's 11 minus 5?
6.
6. So that should be a 6. That's a less than or equal to. Okay. All right. Now from there, Austin, what do you think we do?
You divide every side by 3.
Good. Divide every side by 3. So when I divide by 3, -3 is less than or equal to n is less than 2. Now we got to graph that. -3, there's going to be a solid dot. At 2, there's going to be an open dot. And we want to connect everything in between. So those are all my answers. How many actually answers are there, Maddie? Infinite. Infinite. So I can only list like 0.2, 1.8, 1.97, -1.38. All those work. There's an infinite number. We don't want to list them all. That's too many. All right, so that's with the word and. Okay, now flip it over. Okay. The word or changes things. Okay, the word or changes things. Okay. So if you think about it, at some point, Mr. Parker and I will retire. Let's look at the word and versus the word or. So what if it said you had to work 35 years and be 60 years old? Or it said work 35 years or be 60 years old. Are those the same or different? Different. All right. So in order, if it says the word and, you have to satisfy both conditions, right? You got to be 60 years old and have worked 35 years. If you're 55 years old, you still got to keep working. You might work more than 35. But it says the word or, you can retire at one or the other. Okay? So you got to be careful whether it says the word and or says the word or. That's going to change things. Now here's the word or. If it says x is less than 0 or x is greater than 10, you have to include all the answers that are less than 0 and then include the answers greater than 10. It's called a union. Okay, it's called a union.
Yeah, ors, guys, always go away from each other. Okay, ands go towards each other. Okay?
Right, now we're just going to jump into an example. You cannot write an or like trapped in between two numbers. Doesn't work. You have to write it as two separate problems. So we have to solve these separately. So 8 plus t is greater than or equal to 7. All you're going to do is subtract 8. I get t is greater than or equal to negative 1. Or 6 plus t is less than 2, subtract 6. I get t is less than negative 4. Now you just graph those separately. Okay, so you got that, you got a line down there, that number line at the bottom. Go ahead and scale that off. And so for me, I already have this. So t is greater than or equal to negative 1. Solid dot at negative 1. And then I'm going to go to the greater than sign, which means I'm going to go to the right. Those numbers are bigger than. Less than negative 4, open dot. Less than negative 4. I'm going to go to the left. So like he said, they're going to go away from each other. Okay? All right, you do, once you get that done, I want you to do B. Okay, and we're just going to come around and just double check what you got. Oh, she had
I don't know where they're at. Okay, so I'll wait there in my room. If they show me, I don't know what it's gonna say on their phone. So, it just says on my schedule. So,
Yeah, okay.
All right, good. What you got for me? Oh, shit.
Oh, so she's out.
I don't know, she must be, she has to be. Oh, that's positive.
Yeah. Okay. All right, hey, for this next one. 1, what do you think we do? 7x is greater than or equal to 21. Divide by 7. Okay, so what's that give me then? X is greater than or equal to 3. Good. Got that. Jeff, how about 2x is less than negative 2? What do we do there?
Divide negative 2 by 2.
What's that give us?
Negative 1.
Tell me what to write.
X is less than negative 1.
X is less than negative 1. All right, I agree with that. Greater than or equal to 3. So you go down on your number line, solid dot, shade that to the right. Less than negative 1, open dot, shade that to the left. So any one will work in that answer. The only ones that don't work are in between those. You have to just make it true for one of them. Doesn't have to work for both of them. Okay, that's the difference between the word and the word or. Doesn't have to work for both. Okay, so that's just solving those inequalities. Now you might also see something like this. You might be given the graph. Let's see what it says. It says, all right, write the compound inequality shown by the graph. All right, what would I write? You see this graph, you see it's shaded. It's in between negative 9 and 2. We're going to do it 2 ways. Ava, what do you think?
Negative 9 is less than x, and x is less than negative 2.
Okay, and so you don't need to write the x twice, even though she said it. You just do it like this. Negative 9, write that down. Negative 9 is less than x, less than negative 2. All right, how do I write it with the word and? I'm perfectly fine with this, but I want you to show the other one. I want you to write it as, how do we write it as 2 separate ones with the word and? Okay, Mason?
Negative 9 is less than x, and
I'm gonna have you write the x first though for that. How would you write the x first?
x is greater than negative 9,
Good.
and x is less than negative 2.
All right, good. So both of those are good. Bigger than negative 9 and less than negative 2, or you could write it trapped in between 2 numbers. What about that second one there? All right. Think about how you're going to write that. Mason?
For the first one, x is greater than negative 3.
Is that bigger? Are those bigger than
I mean,
anything?
x is less than negative 2.
And then what about since it's a
X
solid there?
is, less than or equal
Okay, x is less than or equal to -3. Then what?
to. Then X is greater than 2.
Or equal to? All right, there's one thing he has to add.
The or.
Got to add the word or. Okay, you got to add the word or. Can I write this any other way? Nope. If they're going opposite directions, you got to write it as two separate statements with the word or. X is less than or equal to -3, or x is greater than or equal to 2. If it's trapped, okay, then you can get away with the -9 is less than x is less than -2. So we've done the picture, we've done the equations first. The last case here is if they kind of give you a sentence. Okay, it says write each sentence as an inequality, graph each inequality. Okay, so we're going to do that.
Guys, what two words am I going to really focus on? What's in the sentence?
Greater,
Nice.
greater than and less than.
Well, yeah, that's important too. But what else?
And or.
And or, right? We got to see if it's and or.
Okay, I see right here. The number x is greater than -8 and less than or equal to 4. All right, so I want you to think about that. What's that going to look like? How are you going to write that? Okay, Ellie?
-8 is greater than x. Like,
Like that?
yeah. And then you do the less than or equal, then you do the less than or equal to 4.
All right, you got one little thing that we got to watch here. And I know it says, this says a number x is greater than -8. And that's how you would picture that. But what are we doing? We're actually,
Putting the x in there.
we're putting the x and the 8 and we're flipping those. So if that number is bigger than -8, then it also has to be pointing towards the -8. When we're doing this case here, writing it with two things, both of them will always point the same direction. Okay, so x is greater than -8 means -8 is smaller than x. So this is what we have to, they have to be both going that direction. So that will work right there. Okay, so you just got to watch, make sure they're not pointing towards each other or opposite directions. Okay, they need to both be pointing to the left. Smaller number always goes first. So -8, open circle, and then we got 4. Okay, in between that.
Is 4 part of the solution set, guys? 4. You think so? How many say yes? Yes, or equal to on that side. Good.
So now I would prefer this way. Now, if, given the option, you could also say x is greater than -8, but then you would have to use the word and x is less than or equal to 4. Remember, those are equivalent. Okay. A number y is at most 0, or at least 3 halves. Now, at most or at least tend to throw people off at times. At most or at least. Okay, what do you think? Let's just do what? Number y is at most 0. What's that going to look like? Ava?
Y is less than or equal to 0.
Y is less than or equal to 0. Good. And we got this word or here. Okay. Now, how do I write at least 3 halves? Okay. Go ahead.
Y is greater than or equal to 3 halves.
Yep. At least is greater than or equal to. So y is greater than or equal to 3 halves. So let's graph those. Less than or equal to 0. Solid dot to the left. Greater than or equal to 3 halves. All right, now 3 halves, where's that between? Got to be between 1 and 2, right? And so actually, do you have the same thing, or do you guys get them like yours? So you had the same thing. All right, good. So you're gonna get 1.5 there, and then to the right.
Remember, guys, if we're graphing an or, the graphs don't overlap, right? They go in opposite direction. There should be a gap between them for or.
All right, get started on this, and get done as much as you can here in class. So 1 through 12 all on page 93.
What's up, man?